Welcome back, dear students. We are going to start with next unit. However, already the videos of this electrical measurements I have done previously during the COVID lockdown period, but I am doing it again for the sake of better understanding, clarity, as far as the video is concerned, to improve the quality of the video, to be very frank. Okay, so now I'm going to start with the new unit, electrical measurements. Okay, see, whenever I use the term measurements, the first and foremost question that I should ask to you is, what is measurement? Because you are studying this about this measurements, right? Measurement techniques, standards of measurement, different systems, right? Unit system, SI system, MK system, etc., etc. You are already studied all these things. What I am really interested in knowing is, can you define what is measurement? Need not be an engineering definition, but what is your understanding about measurement? Okay, so let me just shoot up this question to you. What is measurement? Pause the video and answer to my question. Okay, that will assure you that, right, how much you understood from your previous study. Okay, right. Measurement, according to me, is a kind of comparison. Basically, it's an act or result of comparison. Comparison between what? Comparison between the given quantity and the quantity which is predefined, predetermined, or a standard. Right? For example, one bag of rice is given to me, and I want to find out what is the weight of this. So what do? I'll compare the weight of this rice bag with the standard weights that are given. I will put 1 kg pan and I'll find out whether both are equal or what. If not, if the rice bag is weighing higher than that 1 kg pan, I'll put 5 kg pan, and now I will check whether both are weighing the same or what. Right? This process I've been continuing till the standard defined weight and the weight of the given quantity becomes equal. So in that, when both become equal, I can state that yes, the weight of the given rice bag is equal to, say, 5 kg. So in this way, basically it's an act of comparison between the given quantity and the standard quantity, or predefined quantity, or predetermined quantity. Okay, so this is basically measurement. I will not go in depth, I will not revise everything. I'm just reviewing few fundamentals that are required for my further discussion. Okay, now when you know what is measurement, can you define what is a measuring instrument? Naturally, the instrument which is used for measuring any quantity is called as a measuring instrument, isn't it? So there are different types of measuring instruments. Apart from that, I am really interested in measuring the parameters that are related with the electrical engineering. Okay, which are the parameters that are really important for us as an electrical engineer? I am interested in measuring voltage. I am interested in measuring current. I am interested in measuring the power consumed by the load. I am interested in measuring the energy consumed by a load. Okay, I am interested in measuring the power factor of the circuit, etc. So these are the few parameters that we are really interested in finding out. Okay, so you already have studied in detail about the voltmeter, about the ammeter at your PUC level. So I will not go in detail about the measurement of voltage, measurement of current. So what I am trying to tell here is, you are already having some prerequisite about this measurement subject. So I will not deal right from the fundamentals. Rather, I am interested in discussing further part of it. Okay, so when you know how to measure voltage, when you know how to measure the current, what are the construction features of these voltmeter and ammeters, right? How that can be extended further to measure the power and to measure the energy. Okay, this is why I am really interested in knowing. See, there are few more parameters that we are really interested in measuring apart from these parameters, like the circuit parameters, how to measure the resistance, how to measure the inductance, how to measure the capacitance, right? And what are the different instruments that are there, how do they work? This is what basically we are going to understand in this particular unit, okay, in the electrical measurements. Right, let me start with the unit electrical measurements. See, when you know what is measurement, when you know what is measuring units, measuring instrument, how do we classify this measuring instrument is very important. See, there are variety of classification. There are different methods of classifying the measuring instruments. Few I have discussed, not all. Broadly, right, measuring instruments are classified based on the type of quantity that the instrument measures. Broadly, this is a very broad classification. What type of quantity the measuring instrument will measure. For example, voltmeter will measure voltage. So voltage quantity is being measured by the voltmeter. So I will put it as a separate category, voltmeter. Okay. Again, in that voltmeter, there could be different categories like analog meter, digital voltmeter, right, or true RMS reading voltmeter, etc., depending upon the working principle. Okay. So, however, see, broadly, how do we classify these instruments are by the quantity that they measure, right? For example, ammeter, which measures current; voltmeter, which measures voltage; wattmeter, which measures power; energy meter, which measures energy; frequency meter, which measures frequency, etc., etc., etc. So this is how one way of classifying the measuring instruments. Second way of measuring, classifying the measuring instrument is based on measuring method. How do they measure it? Do their output depend continuously with the change in the given quantity, or do they take the values randomly, right, or at the discrete intervals? So by this method you can classify these measuring instruments again broadly as analog instruments and digital instruments. Most of us are using these analog instruments as well as digital instruments. Both have their own advantages and disadvantages. So you can never say that this is superior, this is inferior. I can replace these analog meters by the digital meters. No, they have their own advantages. So you can never replace, as of now, you can never replace the analog meters completely by the digital meters, because they do have some drawbacks as well. Alright, so what is analog meter? See, something like this, wherein you are having some graduated scale inside the meter and you have a pointer over there which is moving over the graduated scale. It is showing something, right? So here in the photo, that what you are seeing, image what you are seeing is of ammeter, right? Some ammeter. This is taken from the Google source, okay? And you can see the value what the pointer reads. Based on that, I will come to know how much is the current after connecting it into the circuit, right? And what type of digital meters? Yes, this is an example of a digital multimeter. You must have used already in the lab, isn't it? So here you have a display wherein the quantity which is being measured will be displayed on the LCD display. So simple to read here. So very easy to use this, convenient. But it has some disadvantages also, right? So I will not go in depth of the merits, demerits associated with each category. I am just trying to give you the preamble required for my further discussion. So analog instruments, digital instruments. This is another way of classifying the measuring instruments, right? Now, if I talk about analog measuring instruments, analog measuring instruments could be further classified into three types: indicating instruments, recording instruments, and integrating instruments. What do you mean by indicating instruments? Indicating instruments indicate the magnitude of a quantity which is being measured. For example, is ammeter, which I have shown in my previous slide. This is an indicating instrument. It indicates what is the value of current. Okay, it's basically a indicating instrument. Remember, its value do change with a change in current continuously. If current changes, the value, its pointer will show some other reading which is proportional to the current flowing through it, isn't it? So it's an analog meter and its value will change. Okay, next. We are having recording type of instruments. Yeah, further you see, these indicating instruments are classified once again as electromechanical instruments and Electronic instruments. So this is another classification. What do you mean by electromechanical instruments? Wherein you are having electrical system combined or clubbed with mechanical system also. You are having a pointer, you are having a spindle, you are having a spring arrangement, or maybe a gravity or pull arrangement, etc., etc. Right? Some mechanical moving arrangements are there, as well as you are having some electrical system, you are having coils which produces the force required for the pointer to move, etc. And such systems are called as electromechanical instruments basically, and these electromechanical instruments are further classified as induction type. And what is another type? Yeah, exactly. So two types you are having, right? Induction type and dynamometer type. Okay. Next, you are having electronic instruments, right? See, again, this is a category which comes in analog meters only, analog instruments which are having some circuit. Instead of having the mechanical system, rotational system, it is replaced by some electronic circuitry which measures the voltage, which measures the current or given quantity, and it is, it will display it on the board. So your DMM need not be a digital system. Remember, your DMM need not be a digital system. It can have analog ICs inside. It can have analog circuits inside also. Okay. So just don't get misled by the type of display that you see on the instrument. Some are analog still. So how to identify between analog and discrete is, if the reading changes continuously with the change in the input, they are analog only. Okay. Next, you are having recording instruments. What do you mean by recording instruments? The recording instruments are those which give you the continuous record of the quantity, which is being measured. For example, recording voltmeters which are used in the substations. In the substations, they are using recording voltmeters, and it is recording the voltages instant by instant. Okay, so such instruments are called as recording instruments. Then you have one more category, integrating type of instruments. What are the integrating type of instruments? Integrating instruments totalize the events over a specified time. For example, if I am interested in recording, if I am interested in knowing ampere hour rating, then such instruments will correspond to this integrating type instruments. So they multiply current with the time and they will record the readings. They will add up the reading, all the instantaneous values, they will add it up to find out the final average value, ampere hour rating or watt hour reading. Okay, so basically energy meter type of instruments which will totalize the events over a specified time. Okay, so this is how do we classify analog instruments. So indicating instruments are those I have already discussed, right, which will indicate the magnitude of the quantity that is being measured. For example, voltmeter, ammeter, etc. What are the essential system in these meters? They have three different types of systems. One is the deflection system, another which produces the deflecting torque. What is deflecting torque or force? Deflecting torque or deflecting force is a force which is produced in order to move the pointer, and this force or torque is proportional to the quantity which we are interested in measuring. Okay, so deflecting torque is responsible for producing the force required for the pointer to move over the graduated scale, remember. Next, you have something called as a controlling system. What is controlling system? Controlling system is one which produces the controlling torque or controlling force. What do you mean by controlling force? It is a force or torque which is equal in magnitude to that of the deflecting torque but opposite to the direction of the deflecting torque. Okay, it is equal in magnitude and opposite to that of the deflecting torque. Okay, so why such controlling torque should be produced? If there is no control system, if there is no controlling torque, then pointer would move continuously. It will show a reading greater than that of the specified or expected reading, isn't it? So to limit such thing, we require a controlling torque which can do this. also controlling torque, it will produce one more function. What is that? It will see, as soon as your measuring, measuring is over, the pointer should come back to 0. Pointer should come back to 0. But if you simply disconnect the circuit, pointer will not come to 0 in the absence of control system. Pointer should be reset to 0. That function will be done by this controlling system. And how it can be done? Very simple, spring arrangement. Put some springs. Okay, springs can again pull it back to the original position or 0 position. Okay, so spring arrangement, very simple type of arrangement which will be used apart from this gravity, etc., etc. Okay. Third system is a damping system which produces a damping torque. See, basically this damping force is required because in the absence of damping force, pointer will move. It will start to move over the graduated scale, right? And it will reach the final position where the controlling torque and deflecting torque becomes equal, because both are operating in the opposite direction. So when they become equal, it is going to stop at that position. But before it come to steady state, it will not stop suddenly because of the inertia of the pointer, because of the inertia of the moving system. It keeps on oscillating between the steady position. So to damp it, to bring it to the steady state or equilibrium position quickly, this damping is used, and very commonly air friction damping is used. So this is what that is, the functions of these three systems are shown very clearly in this particular diagram. Again, once again collected from the Google source. Look at this source, very simple. This is a moving system, and which is pivoted on the spindle, and the pointer is also connected over there, right? And you see this is a graduated scale. Pointer is moving because of the deflection torque or deflection force. You can see deflection force is in this direction. As soon as it starts moving, there is a spring over there, and this spring produces another force, okay, which is called as controlling force, and it is opposite to that of my deflecting force. Okay, and pointer will now come to this position where this controlling torque and deflecting torque becomes equal. So, okay, but it will not simply come to the rest at 2, for example, in this case. Okay, it will not come to the rest suddenly. Rather, when they become equal, it keeps on fluctuating or oscillating between its mean position, and for that case we require damping. Okay, so I hope you understood. In any analog meter, three systems are mandatory, compulsory. One is a deflecting system, controlling system, third one is a damping system. Any doubt here, please let me know before I go further. Okay, and if you have any doubts, if you want further clarification on these things, right, you can write that in the comment box and you can send it to me. Okay. All right, let me move on to the next one, wattmeter. Let us try to understand the construction and working principle of a wattmeter. Okay, what type of wattmeter we are trying to study here is a electrodynamometer type wattmeter. Electrodynamometer type wattmeter. See, electrodynamometer type of wattmeter, basically this figure shows you the construction of a electrodynamometer type wattmeter. Okay, what is wattmeter? Before I go further, please understand wattmeter is something which is an instrument which measures the active power. Remember, and what is the active power? What is active power? In case of a DC circuits, this active power is nothing but voltage multiplied by current, isn't it? Active power P is equal to V into I. V and I are RMS values, okay, not instantaneous values. And in case of AC circuits, right, this active power is equal to voltage multiplied by current multiplied by cos phi. What is this? This is nothing but a power factor of the circuit, okay, and this phi is nothing but a power factor angle. power factor angle. What is that power factor angle? It is the angle between voltage and current. So basically a wattmeter is something which measures the active power consumed by the load. Whether it is a DC or AC, same instrument can be used to measure the active power. Okay, now let us try to understand the construction of a wattmeter. Basically, wattmeter has two coils. One is called as a fixed coil, okay, and that fixed coil is split up into two, okay, and that coil we are calling it as a current coil. Why I call this as a current coil? Because this coil is connected in series with the circuit. Look at this path. Current is going to flow through this coil as well as this coil and through the load. So what I mean to say is, these current coils are connected in series with the load, so they can sense the load current. Whatever you see, whenever I am interested in measuring the current, I should connect that in series with the load, isn't it? Ammeter also we connect in series with the load so that it can measure the current which is flowing through the load. So same way, current coils are connected in series with the load. And how these current coils are? Basically, these current coils have few turns of thick wire basically. So they can carry current equal to that of the load current, okay, rated basically, and a few turns, okay, so that the resistance is less. So resistance of the current coil, if you consider, it is very, very less. So it will not make any difference as far as current flow in the load is concerned, even if you connect that in the circuit. Okay. Next you have something called as potential coil. One more coil which is called as a potential coil. This coil is connected to the pointer itself, to the moving system itself. So the potential coil is pivoted on the spindle itself, and to that pointer is attached. This pointer will move over the graduated scale, and this current coil has thin and more number of turns. So it has more number of turns. So if it has more number of turns and the lesser cross section area, that means it has more resistance, right? And its resistance is further increased by connecting a resistance in series with the potential coil. Okay, so this coil will be connected in parallel to the supply. And which instrument we connect in parallel to the supply or parallel to the point? It is a voltmeter, naturally, to sense what? Voltage across those 2 points, isn't it? So similarly, this potential coil is connected across these 2 points. You can see it is connected here, other end is connected here. So it's a parallel connection. Basically, it senses the voltage across these 2 points. How it will sense? Because of the very high resistance, very small amount of current will flow through the potential coil, and the current flowing through the potential coil, right, if I consider it as a I2 current through the potential coil, is proportional to voltage across the supply. So in turn, see, whatever current that is flowing through the potential coil is proportional to voltage. So what this is sensing is indirectly what I can say, it is sensing the voltage, this is sensing the current. So as far as DC measurement is concerned, you see voltage is sensed, current is sensed. So interaction between the two will give surely the active power. Okay, so I am interested in mentioning about the construction. I have not discussed about the working principle still. So I will consider, I will take up this working principle in my next video. Thank you very much.